Morning everybody, Gary Porter again. I'm going to take you through what I'm doing for parts here. And this blue beast is the pure sine wave inverter. Takes 12 volts in. This whole system here is running on 1.9 amps at the moment from the battery. And I got a variac here that's now set down into right around a little under 40 to 50 volts going out to this. There's a 9 kV neon transformer back here, a high voltage probe, and my spark gap's right over here, and uses a couple of neo magnets to blast away the arc. And I got L1 here, which is 6 turns of 148 pieces of 28 gauge copper wire, all put together into a single set of wires to make the 6 turns. I've got it running basically almost outside the L2 coil because I'm getting so much voltage out of L2. I don't want to fry my IGBTs. And then over here we've got these are 820 microfarad 500 volt caps. I've got 4 in parallel for the positive side and 4 in parallel for the negative side. I'm only working with the positive 2 microfarad cap right now. That'll go up to 2000, and then it gets discharged into this positive bank here through this L coil here, which is 3.3 millihenries. There's a couple of diode complexes here, 5 kV and 10 kV in series, giving me 25 kV at 15 kV at 15 amps. So I can that's taking the back EMF from the coil when the IGBT breaks a connection, and helps also pump the negative energy into the ground of the blue 820 microfarad cap bank. And let's fire it up here, and it'll take it a second to get going. And I'll turn on the I've got a scope set up over here. And you can see this, the number 2 trace here is at about 70 volts. When it hits the second centimeter, that'll be 100 volts. Right now the 2 microfarad cap isn't even reaching maybe, I don't know, 500 or 600 volts, and right now it just hit 100 volts, and you can see the high voltage cap is now going up to 1000, and it climbs up a little higher, and then all of a sudden you'll see it dip down. That means that the IGBT is turned on, and there it goes. And that's actually because the 100 volts is now dropped down some out of the 820 microfarad cap, and that's it for that. Anyway, this circuitry here has a comparator in it, and I don't know if you can see that or not, but it has a comparator, an opto-isolator, and a little 604 driver for a pulse transformer that goes into the IGBT, which can handle 2500 volts at 55 amps. And what I found out was, if I just leave everything off but leave the power supply board on with the plus or minus 15 volt power supplies, then the IGBT driver gets extremely hot because it's just on constantly, and it's trying to turn on the IGBT. So I smelled something burning, and I said, okay, well I better turn this off. So this is off now, and no smoke today, and that's it so far. And the L2 coil over here is tuned with a capacitor across it, that is, give me 1 second. That capacitor is 2.001 microfarad, 1600 volts in series, and 2.2 is in parallel with that, nanofarads in parallel with that. So you got 2.25 nanofarads across the entire L2 coil, and L1 is using 20 nanofarad in the spark gap area. And that's it for today. Have a great week. Bye.